So like I was saying, for this object-oriented programming part, was it section 10? This definitely tends to be one that melts people's brains a little bit. And that's not to scare you guys. It's just more like, it's definitely a different way of thinking. It's much more of a philosophy of programming that's built into programming languages. So you'll see like some older programming languages don't have object-oriented built into it. And it's because they were built before object-oriented programming was a thing. And we'll also call it OOP, just know that if you see that abbreviation. But I'm going to tell you is that if you were a computer science major, we would be spending at least the next 6 months talking about and using object-oriented programming over and over again until it like basically became part of your soul or something like that. In reality, we're not going to spend all that time because we're not computer science majors. I would recommend, trying to practice it out and making it work. But the important part is going to be understanding code that's written in OOP in that style, and also be able to write your own code in that way too. A lot of the reason why we do this too is because it's, first of all, well, we'll talk about the reasons why, but the biggest reason why is because it's really common. It's kind of like you'll see code written in this way. And in fact, you might not have realized it, but you've already been using object-oriented programming within your code. You just haven't like realized that's what it was doing. So in a lot of ways, we're already using it. It's just like we're going to go dig deeper into like the inner workings and stuff. Cool. All right. So let me go ahead and open up my guy and share my screen. So I guess I'll go. And the good thing is that this notebook, as well as yesterday's notebook with Jeff, that should now be online. I shared that on Slack. So if you're trying to look to like go through it yourself, including that like last what's it called, that last exercise that was done, that will be up there too, so that you can try that out.
Can I ask you a question, Victor?
Yeah.
So like going through the labs, they're having us like write these definitions to like do certain things within the classes. And I'm definitely like having to look at the answers a lot for that. And I guess I'm just wondering like I understand what we need to do, but I feel like I'm still not like very comfortable with that part of coding and like figuring it out on my own. So I'm getting like a little bit like caught up and nervous that I'm behind in this topic because I'm not completely comfortable with the definitions. Or do you think that that's typical at this stage, and like to just keep like moving forward, because really you're just learning about like setting up the classes and the self and what that means? And
Yes, definitely. For this subject, I would say is that if I gave the option, I would say we should do 2 sections of object-oriented programming. It takes a while for it to really like sink in on how it's used. That's what you're talking about, right, Lauren?
Yeah, I just feel like like with some of the definitions and what the labs are asking, I'm spending a lot of time like trying to figure it out, and then like just not getting there, and then looking at the answer. And I know that we've already gone through like defining variables and stuff like that, but I guess I'm just worried that I'm behind, I guess, already. So I don't know, I'm trying to get a sense of how worried I need to be about that versus like learning the overall, like what OOP is overall. And
yeah. Sorry, I didn't mean to cut you off like that, but I would say overall, like if you think about how long you guys have been doing like in this program, it's been like just about a month if we include the break. There's like you guys are basically getting through that practice of like going through. So that's a pretty common thing I hear, is that people are kind of like, I don't feel like I have it completely solid, and especially when we get into OOP where it's very computer sciencey based, and it feels very much, sometimes people are like, I feel like I should be at a better level at what I am. We'll actually do a pair programming. I'm going to assign a pair programming activity afterwards, which I think will be really useful for people to be able to pair up with each other, maybe groups of 3 even, but basically kind of what we did at the very, like, I think first week or second week, and work together. And that way you can also see each other work a little bit and get a feel for, how everyone's doing. And hopefully that also helps you just practice. I think sometimes having that someone else there is kind of like reassuring in a lot of ways. So hopefully that kind of answered your question, Lauren. But
Yeah, kind of.
mhm, yeah.
I guess, yeah, I just don't want to like get caught up on something that it's like, oh, you'll figure it out the more coding that you do and not get
Mhm.
like defeated or determined.
Yeah, and we can definitely talk like on this goes for anyone. For one-on-ones, we can talk about parts that you're like, I feel like I'm really stuck on this part. Should I focus more on this? If there's specific parts, you're welcome to ask on Slack too, right? Like, don't
Okay.
feel like if
Yeah,
you
we
want to
just
put
don't
in,
have like a one-on-one this week. So I
yeah, I know
don't
because
anticipate
assessment, right?
that in our class.
Yeah, so definitely use Slack and stuff like that. And then obviously, when we do have one-on-ones, welcome to bring that up and everything too. Um, what's it called? I would say the big parts is making sure if knowing how to use pandas, like do you need to know all the parts of pandas and like how to manipulate every part of the data frame? No, like I wouldn't say at this level that you would have to do that. In fact, I think even at the end of this course for people who have been past a couple years, they find new things in pandas and like Python in general of just like, oh, I didn't know you could do that. Those are kind of natural things that you kind of get as you do it more and more. But I think at this level, knowing what a list is, knowing how to go through a for loop on a list, being able to create a data frame by reading it through a CSV or something along those lines, basically creating a data frame, and then understanding how to get a column, how to get a row, or something along those lines, or add a new column. I think
Okay.
those would be the things that be like at this level, that's what you should feel at least somewhat comfortable with. It might take a second, but you can probably get to it if given like a couple minutes or something.
Yeah. Okay. That's
Cool.
helpful. Yeah. Because,
All right.
yeah, just some of like the for loops and the definitions are just like pretty
Yeah.
heavy.
And and that will come over time as well. As you see it more and more, it'll be easier to kind of like say, oh, okay, I've seen this a few times.
Okay. Thank you.
All right, no problem. Okay, good. Then that was kind of a good overall thing, before we dive into this part. So thank you, Lauren, for sharing. Um, okay, cool. So we'll go into object-oriented programming now, right? So some of this will be mostly review. I'm not going to go through everything that the curriculum goes. I'll be honest with you. For example, we'll probably won't get into go into inheritance. We'll probably not get completely into self, but we'll get a decent start. So first thing, object-oriented programming, what is it? How's it structured? Why are we doing this? So basically, it's how our programming language is structured. Now, there's kind of different ways you can break this down. There are procedural languages. Basically, it's a bunch of code. If you imagine, like, if you just were given code to begin with, like, how do you write this stuff? So you can think of like really early programming languages like C, Fortran, the really original. I don't know if you guys ever had those like TI-89 calculators and stuff like that. You can program on there. I don't know if you guys even know this. You can make programs in there and you have to use these things like go to. There's no for loops. It's basically just go to parts and stuff like that. It's really funky. But basically like that's like the really beginning part where essentially you just have a bunch of code and you just read it all the way down through, which to be honest, it's pretty difficult to program in those ways. C is actually a huge plus. Fortran, I don't know if anyone even knows Fortran anymore. I still know some people who in physics who still use Fortran for specific reasons. Fun fact is that if you okay, there's a lot of people who know these programming languages because there's satellites up in space and you can't go up there, from the 1970s, 1980s and upgrade, the system or whatever. So you're stuck with so many kilobytes of RAM, if that. So they have to use these older languages. But these are usually considered procedural languages, okay? Not that they're older, so they tend to be older, but there are some newer ones like that. We also have functional programming languages, which are more mathematical. Haskell is a classic one that's used in academia. OCaml is more industry. Basically, these ones are, there's only inputs and outputs kind of deal. They're in a lot of ways, there are no variables, which is kind of weird. But anyway, the idea here is that this is another style of programming. And then there's object-oriented programming. Classic languages that are associated with OOP are Java, Python, JavaScript. Note that any of these languages, like for example, Python, can really be thought of as any one of these, though it's classically thought as object-oriented programming because it's built into the function. So just know that it's more of a philosophy of style, and some of these programming languages are associated with these parts, but can be transformed with that philosophy in mind. So just kind of know that that's kind of like what you can do, okay? So this kind of leads into what is OOP in general. So basically we use the concept of these objects and classes. So you can think of it like a mold or blueprint. Okay, so you can think of a class. When we say a class, we can think of it like a blueprint or a mold. I'll use the analogy of a mold more often because I kind of like that one better. And then an object is basically some manifestation of the class. Basically, you can think of like a mold, and we pour in our plastic, and we get like, this little toy or whatever, and that is our object itself. Similar with a blueprint, we have the blueprint, we have the how to build an object, we build that object, and now that object exists. If we change the blueprint or if we change the mold after we made the object's not going to change, right? The object's already made. That's kind of like that analogy. And you'll see basically this whole thing is an analogy or metaphor of like how we think of our programming parts. Okay, so basically we have classes, which is kind of like the mold and blueprint, the objects, which are the actual like things, right? Objects. And then we have things like attributes of a class and attributes to an object. So you can imagine like if we have this class, like this is a good example right here with this diagram of a class. So like you can think of like the concept of car, we have wheels, we have the shape, whatever, but maybe the object itself, we actually can say, well, okay, we have the object, but let's make it green, or let's make it a Mercedes or a BMW or whatnot. Someone has expensive taste over here. But anyway, is that you can change the attributes of an object. You can also change the attributes of the class and say, okay, well, by default, this will always be made blue, but then afterwards actually changing it, the object itself. So you'll see us do this back and forth. Now note that if just like in real life, if you change the class after making the object's not going to change, right? If I change the blueprint of a BMW, my BMW, I don't have a BMW, but like a BMW in like the driveway or whatever, isn't going to change based off that blueprint. Okay, and that analogy will be really useful for us as we kind of go through this. Okay, so then the next part's really like, all right, that's interesting, but why do we really care? Like, what's the whole point of using this, object-oriented programming? Well, basically, it's that it's the modern way of programming for the most part. The other opposite, it's functional programming, which is kind of a different kind of way of programming. But for right now, pretty much everyone's programming object-oriented programming. You can see basically the main jobs right here: Java, JavaScript, C#, Python, and this is collected from another insight, indeed.com. But basically, up to about C++. Even C++ has like object-oriented programming that you can kind of build into it. These are like almost every language on here has ability to use object-oriented programming. And so basically it's like everyone is already using it. And it's a really convenient way of actually doing, doing your programming, or do your program and everything like this. So it's really a great way to like organize your code with an analogy. So we kind of have this idea, it's like, oh, we have this class / mold / blueprint to instantiate, to make an object and stuff like this. So basically it's kind of nice to say, okay, whatever we're making is a thing. And those things can be like physical objects, like I said, like a car, like we can program like a car object, but these can also be like a method of network protocols. It's like, well, this network protocol is a thing, and we can modify this thing, which is a network protocol. And it makes it a little bit easier to kind of, organize our thoughts. The way I kind of think of it is kind of like a function on steroids. That's really what a class is, kind of a collection of a bunch of different things. And you'll see when we write actual code for classes, it looks a lot like how you would write a function in Python itself. Okay. And last thing, it's just flexible. So we can take a class and we can do things like modify that blueprint, modify that mold, make a copy of that mold, and then change it. We can do something called inheritance, where basically we start off with this main copy and then say, well, okay, what if I want to change a vehicle to a car, or a vehicle to a motorcycle? Well, both of those travel on the road, for example. Those have similar attributes, but they're also very different. For example, a motorcycle rides maybe 2 people at most, versus a car has a lot more options in that case, or the way it's built and stuff like that. So they're similar, but they're different at the same time. So this allows us to be very flexible and makes it really easy to not have to reinvent things over and over and over again. Okay, one example of this is kind of like I mentioned about NumPy arrays. NumPy arrays are really an object. It's object-oriented programming. And so NumPy arrays are actually used to build up series and data frames from pandas. So basically, pandas didn't have to reinvent the wheel of how you make it an array, essentially. It can use that object already and basically inherits those properties from NumPy arrays into data frames. And that's how we can do a lot of similar operations on top of it. Okay. Cool. Sound good for me?
Good question.
Yeah, go ahead.
So like things like NumPy are an OOP. And so we are able to like pull that and utilize it. But when we create these classes and OOPs, like nobody else can use them, right? Because it's like within our like
on your computer,
yeah.
right? Yeah, you're right in that way, in the sense that like it's on your computer, so only you can use it. But what's kind of cool is that you can just like simply share out this set of files. Like Lauren, since I know you've kind of gone through halfway through the curriculum, when you can make these own files like .py files, which are just specific classes, you can go ahead and send that over to Jenny or send it over to Andy, and they can actually use that and run it on their own machine as well. What's really cool too, they can actually take that code and then modify it themselves and make it, it's like, okay, let me make a different, you know, like ancestor of this, or not ancestor, but descendant of this. Like, let me modify this and make it slightly different, and it can still work with your old class. Essentially, like NumPy, that's actually what you're doing. Someone else, well, in this case, a group of people wrote NumPy, and when you did a pip install or install through Anaconda, you actually are just downloading a bunch of files someone made, basically, and you're keeping those on your computer. And so whenever you do import NumPy, basically what you're doing is literally your computer's looking for those files and importing the code so you can use it. So in a lot of ways, like literally writing the class, at least in Python, writing those classes and sharing those things are pretty much the same thing. So cool. Good question. No problem. All right. So this leads us to like, okay, this is cool. Like, it's all about the why and everything, classes, objects. I'm gonna kind of keep saying blueprint and mold. So now we say, okay, what if we want to do something, right? So like I said, a class is basically a blueprint or mold. I'll use mold more often, even though I think classical people talk about it as blueprints. I like the idea of mold because like you pour in plastic. It just makes sense to me. And an instance, which is your object, is made from that mold. So it's still an individual. It's separate from others in the same mold. So if you take like, you know, a mold like for a, I don't know, a toy ballerina, right? And you pour in, you know, some plastic into this toy ballerina and it makes this ballerina, right? It's like, well, then if I take this mold and pour another one to make a new object, well, it's made from the same mold, but they're separate objects, right? So that's the kind of idea there, okay? So here's some very simple code. So we're going to go through a lot of little code. I'm going to walk you guys through it, okay? So this is very similar to the, what's it called, the curriculum, but I'm going to make my own things. I'm going to make robots because we're playing with computers and stuff like that, so it's fun this way. I really like making little robots. So right here, this class robot, this is kind of like similar to define, right, with a function. Classically, we use capital letter to denote that it's a class. That way we're saying, oh, this is a class versus something else. You technically don't have to use capital letters, but traditionally we do. So stick to that convention as much as possible. But this pass right here basically saying, don't do anything. And essentially this makes like a blank template with no attributes. It's essentially like a blank face robot, okay? But now at this point, we can actually make these robots, you know, from these classes. So the way we make a robot, an object, right? Or I'll use the technical terms, instantiate an object from the class, right? Which basically says we pour the plastic into the mold and make an object, right? As we say, we give it a variable, and we say it's equal to robot. So kind of similar to how you would use a function, right? With basically the function name and then parentheses, and we can actually later on pass in information into here. But the point is that we basically are calling our class to make our object. And then we can start saying, okay, here's my robot, and then I can start giving it properties. So I can do my robot.name. In this case, I gave it the name Wally. I can give it a height equals 100. So I can give it, you know, I basically made it out of the mold and started giving it its own properties. So in this case, I made Wally. And this guy's made another robot called Your Robot, and I put the name as Rob, 200 centimeters tall. Okay, and now I can actually see these different properties. So in this case, I'm going to print out my robot.name and my robot.height. Okay, and same thing for Your Robot. And you can see I get Wally 100 and Rob 200. Right. So you can see I kind of can modify parts. So what happens to you guys? What do you guys think will happen if I do my robot.purpose? Since we didn't give it a purpose yet.
You'll get an error.
Yeah, probably get an error, right? So that's right. It says, hey, robot has no attribute purpose. So we didn't give it that attribute dot purpose yet. We haven't assigned it. Of course, if I were to give it dot name, you know, if I replace it with dot name here, you would actually see it actually print out a name. Okay, cool. So then we can actually make something better. So this is nice. Like we can make a little class thing. We can give it some properties, but it'd be nice to give every robot, every time we give it, a certain set of properties as well, right? So one is like we never gave it a purpose. So let's make a class with give it purpose, right? So we'll give it a nice, beautiful purpose to love humans, right? Because we want our robots to be nice, okay? And we can do the same thing. We make our Wally with 100 centimeters, Rob with 200 centimeters. So basically the same exact code, if you notice that, right? And note that now if I do my robot, which remember, I never said explicitly what its purpose is, I can run this, and you can actually see it gives me out a purpose. So it's nice that I built in this default purpose into the class. So it basically it automatically, it's part of its mold, okay? Now, if I make another robot though, to kind of show you what I could do, make another robot, his name's Bender, and I actually change his purpose to kill all humans now. Well, now if I run this, you can actually see, I can call its evil robot name, which is Bender, and then give its purpose. In this case, you can see it's to kill all humans, right? So I can actually override on top of the class's default and stuff. And note that again, if I did my robot again, the purpose didn't change because all I did was change that specific object. Okay, everything makes sense so far? All right, cool. All right, so my next part basically is like, let's start instantiating some more objects using our mold. So here's some more example code. So again, I'm just gonna make my robot over again, same exact code as before. And I can do this now, so like I can have these objects. So I can kind of imagine that I have this robot called Wally, his height is 100 centimeters, and a robot named Rob, who's 200 centimeters. And what's cool is I can actually say, all right, who's taller? Now this code right here is basically one-liner. I don't know if you guys have seen this before, but hopefully it's like relatively easy to read. You can say basically this tall robot, I'm gonna find out who's taller and save that robot there. So if we're say it's my robot if my robot's height is greater than or equal to your robot height. Otherwise, else it'll be your robot, okay? So this is equivalent right here of saying if my robot dot height is greater than or equal to your robot dot height, then tall bot is equal to my bot. Otherwise, else tall bot equals your bot. So this code and this code will do the same exact thing. Sometimes you'll see it this way. I just wanted to show you guys a different way of writing this. But you can see here, it's kind of, what's nice about Python, you kind of read it like English. It's like my robot, tall bot equals my robot if my robot's taller than your robot. Otherwise, it'll be your robot, okay? Does that make sense so far? Cool, all right. So in this case, what should tall bot be? Who is taller based on this criteria?
Rob.
Yeah. Good. Okay, good. So we have this guy. So what's nice is that tall bot will now be Rob, right? So I can just say tallbot.name and then say what his height is. So I can run this now. I can actually see Rob is the tallest bot at 200 centimeters. So what's nice against here is that I didn't have to explicitly say Rob here. I can just say whoever is this robot. So it's kind of like this tall bot is equal to, it's kind of like me pointing to say, which is the tallest robot? And then like pointing at, oh, Rob is the tallest robot. And then when I say, all right, who's the tallest robot's name? I say, oh, his name is Rob. And say, okay, how tall is he? Oh, he's 200 centimeters. That's kind of like how we can do this stuff, okay? And this is why it's super powerful because I didn't have to ever know what these names were. I just had to say who is the tallest robot, okay? Cool. All right, so let's do a quick little activity. This will be fun. All right, all right. So we're gonna build some robots here. So what I'm gonna do for you guys is I'm going to have you guys try out just building on your own, and then you'll basically share it back. And I'll send this through the code and stuff like this. So what we're gonna do, your goal is going to make a new robot. So you basically have this class, new robot, and then you're just gonna have a property for name and a property for weight, okay? So I want to, let's see here if I can show you what this will look like. So what will happen here is I want, just like with purpose here, let's see if I can show you guys. Just like in this class, I gave a purpose to love humans. I want you to give a similar property, name, and weight for this robot, okay? So maybe we'll just do this all together as a class. Does that make sense? Okay, so first of all, I have class new robot, and then I want someone, a volunteer, to say what I should write next. Or do you guys know how to request control? How about a volunteer first?
I'll do it.
Okay, Andy volunteers for tribute. All right, so what you're gonna do is you're gonna find my screen, my shared screen, and at the very top you should see like a little menu on top? Yeah, you found it. So now you should be able to control this part. And just go ahead and write in a way so we can define the property or a property. Oh, can't hear you, Andy, if yours. Here,
yeah. Sorry.
Okay.
I was using like if you hold on space, you could talk, and then it was just like.
I know it's confusing because you're controlling.
Okay. Yeah. So should I set name to be something in particular?
You could give it a name, or you can give it no name or something. You could give a default.
So I could just do like none.
Yeah, that works. Cool. All right, and then wait, or reject, whatever you want to call it.
Close, right?
Yeah. All right, none. So okay, so that means we have some defaults. Thank you, Andy. All right, so I'm just going to take back control. Oops. Okay, cool. So I can go ahead and run this now, and now this basically will have a default name of none, weight of none, and I can go ahead and instantiate this robot. So can I have? Oh, I think someone still has control, right? I don't know how to have you relinquish control. I think it's on the top again. You got it figured out, Andy? Okay, cool. So now if I have another volunteer now, I want you guys to create a robot. So we'll call it robot A using the new robot class. And I want you guys to first instantiate this robot and then actually give it some properties. So who's my next volunteer? All right, Jenny, do you want to go ahead and get control of it?
Yes. Okay. What do I do?
Right, so
remote control. Is that it?
Mm-hmm.
Okay. Oh boy.
I know, such power, right?
Oh.
All right. So now what you're going to do, you're going to instantiate the robot. So using that new robot. Mm-hmm. And you can run that if you want.
Okay.
Okay. And then I want you to go ahead and assign some properties to this object. Since it's just none and none.
Right.
Cool. All right. And then you can go ahead and run the last part. So now that should hopefully run robot A's name and weight. And we can see my name is Jerry and I weigh 42, whatever that 42 is, right? So cool. All right. Thank you, Jen.
Okay.
All right.
Yeah. I'm giving it up. There we go. Yeah.
All right, cool.
So Victor, if like you had a name and a weight in that, like under the class in that, and then later, Jenny renamed it Jerry, but originally it was named something else. It would come up as Jerry, right?
So, but yeah.
Okay.
I have something else right here, right? So if I make a new robot here, and just to show you that it would work this way, right? I have robot A dot name, and it should show up as something else, right? Mm-hmm. And so if I run this now, you'll now see it as Jerry. So you can think of that as like your default, but you can always override it. Okay, cool, good question. All right, and so now let's have someone else. Let's have another volunteer, either Rebecca or Lauren. You're gonna make a new robot with new properties, and then we'll test out who's heavier. So
I can do it.
Okay, go ahead, Lauren. Go ahead and request control. This is good practice in case we ever do this again, so that way you guys know how to control. All right, and now you should have control.
Okay. Okay. Close.
And then,
oh, okay.
Good. Oh, the peppers are hot. Yeah. Yeah.
I'll name it Victor. Okay. Oh, that name.
good. Okay, cool. I am 60, or at least the robot named after me is 60. All right, so now, Lauren, you can go ahead and try this, and you guys are welcome. I'm going to scroll you down here. You guys are welcome to help her out too. I want you to write some code now on comparing robot A and robot B on which one is heavier, and print out who that is.
Okay. So, oh, there you go. Okay, so print notes heavier. And then, so heavy that equals,
And feel free to help her out, guys, too. So,
so
Lauren,
yeah.
do you want to do it in one line, like we saw earlier?
I mean, either way, I guess. So I think it's something like, so heavier robot equals, it's like if robot B dot weight greater than robot A dot weight.
You're gonna wanna put robot B before the if.
Mm-hmm.
Oh, okay. So robot B.
Yeah.
Okay, and then
It's a little
else robot.
counterintuitive. And then else. Yeah.
perfect. All right, cool. And then let's go ahead and print out the heavier robot's name. And who should it be in this case?
Should be Victor.
Okay, and go ahead and run it.
Or do you have to do that name?
You're gonna try it out, see what happens. So yeah, we haven't gotten to this part yet. So go ahead and do .name, and we'll actually explain what that is. But kind of going back, good job, first of all. Good teamwork, everyone. So if Lauren goes to relinquish control, and I can go back to it. So one thing you might have seen, like, what's it called? When Lauren was putting out heavier robot but no .name, you saw this weird funkiness right here. And this right here, and we'll talk about the sense, is like where it is in memory. Essentially, in the computer, there are some zeros and ones that represent robot, well, heavier robot in this case, right? There's some zeros and ones that exist somewhere on the computer. And essentially what this is saying is this guy right here is saying in what part of the memory of the computer does this robot exist? Essentially, it's saying the robot's right here. That's essentially what this is showing here. And so you can see is that this new robot right here, it's at where it lives at, right, is at this space right here. And that's essentially what it's doing. Essentially, it's we call this a memory address. So you'll see this sometimes if there's no default to print out, it'll print out like a specific space in memory, right? And we'll actually see that next. So good. So thank you, Lauren, for actually showing that, because this leads us right into the next part. So cool. Next part is saying we actually take up spots in memory. So if we actually print out, for my robot and your robot, which were Wally and Rob, I believe, you can see here is that they actually have different spaces in memory. So the first one is my robot here. You can see it almost looks the same, but those last two digits are different. And that's because it's a different space in memory. Essentially, it's where they live at, right? You're taking up space, okay? So what's nice is that we can actually use this to figure out if you're the same robot. So just like we saw with Tallbot and Rob, or like, previously, which one weighs heavier, heavier bot and Victor, right? Those were the same robots, right? So sometimes it could be useful to say, are you the same ones, or are you just like a different one, or are you kind of similar or whatnot? So we can actually use this equals and is. So we've seen double equals before comparing two things, like this 3 equals 3. Well, we use double equals. You can also use something is for objects. So objects actually can say, is this the same thing? And that's a little more, more like English, right? And so we actually look at this, for example, my robot, my robot and your robot, right? These are not the same ones. So is my robot and is your robot. Those are not the same ones as well. So you see it returns false. But my robot equals my robot will return true. Okay, so this is basically using it off of memory. So now we have a little game here, right? So I'm making a generic robot 0, generic robot 1, right? Note that I'm not giving them any special like properties, right? So you can think of whatever their defaults were. I think I just gave it a purpose. I think that's all they have, right? So basically these robots should be relatively indistinguishable. But is generic robot equal to generic robot 1? Do we think that will return true or false? So thumbs up for true, thumbs down for false. And just guess, right? We'll test it out in a second. So I see false down this way.
True.
Okay, Rebecca's saying true. Okay, see Andy false. Although it's kind of sly, like, maybe false. So we'll see, right? So it gives it false. And I think, Rebecca, you're probably like in the same mindset of what I think most people would think is like, oh, you know, like, well, they don't have anything different. And the reason why is because this equals part actually compares not the properties of the robot, but actually their memory space. And you can actually see this if I try doing is as well, which, you know, surprise, surprise, also gives false. Okay, and this is usually a little more powerful for objects. But now if I print this out, you can see that they do exist in different memory spaces. So basically the computer for double equals will treat them as not equal to each other. Okay, so that's a little subtle point because, you know, you might think like, well, they aren't any different from each other, but basically this double equals and is will compare where they are in memory space. Are they literally the same object? Okay, so now we have a little extra part. So in this case, I have same robot equals generic robot 0. Okay, so let me ask you guys now, do we think it's going to return true or false? Thumbs up for true, thumbs down for false. So basically the same robot here is going to, I'm just going to set equal to generic robot, and then we're going to test out if these are the same ones. Okay, so I'll give you a little countdown. 3, 2, 1, thumbs up or thumbs down. All right, see some thumbs up. Rebecca, I don't know if you want to share auditorily your answer.
I'm, you know, have to 50-50 chance, right?
Yeah, you got 50-50, right?
It probably is the same, but I'm not sure.
Okay, that's perfectly fine, right? So we try it out, and oh, same robot's not defined because I didn't run this part. So you guys are all wrong now. All right, so let's go ahead and run this now. And you can see it is true. And so that's because, as you guys are probably seeing with me trying to trick you guys a little bit, right, is that same robot is essentially like pointing. And then like if we're in other programming language, we call it a point. We literally call it a pointer because computer scientists are super creative like that. But basically it's like pointing at the generic robot saying, oh, that's that robot right there. So it's kind of like someone speaking a different language. It's like, oh, robot, you know, A over here, and someone calls like, no, robot number 1. Well, they're both pointing at the same robot, so they are the same one, even though, you know, it looks, you know, we don't have the same generic part. So if I actually print this out here, we can see that they're actually the same memory space. So what's interesting though, because they are the same object, the same robot, if I do same robot.name instead of the name, because remember, if I go ahead and do same robot.name, it shouldn't show anything, right? I don't have that attribute. So now if I go ahead and assign a name here, okay, I have same robot.name. Well, same robot.name and generic robot.name, okay, if you didn't realize they weren't the same ones, you might think, oh, well, they're not going to have, one's going to give me an error, right? But because they literally are pointing to the same exact robot object, they actually both have their names changed. So basically because I change one, but I'm pointing at this one, like, oh, change this robot's name. Well, that's same robot, and robot or generic robot 0 is also pointing the same robot. Basically, it changes the same one. Does that make sense? Okay, cool. So this is, to be honest, this is the stuff that can get really confusing for people as you're trying to make code. You need to change something, like, why did this one change and not the other one? These are the things that can kind of come up in weird ways. Okay, cool. So good, we have enough time then to go into the next part. So I'm gonna go into some little extra parts. So how do objects vary? With variables. All right, so we can actually do something similar like we saw. We can set some default parameters like we saw when we were messing around with it in our little activity. We can make our robot now have a name default of none. So that way I won't impose a name on my robot in this case, right? So robot's none. Material is metal, is electric, is true. I don't know of a non-electric robot, maybe it's possible. Number of arms 2, okay? So kind of like a humanoid robot, okay? And I can actually say, okay, let me go make Wally, and note that I never gave it any of those properties as well. So if I run this now, you can actually see that because it has Wally.name, Wally.material, Wally.isElectric, these parts are just basically taken in from the mold, from the class itself, okay? Note that I can still give it, change these variables as well, like we saw before. So we can change things out, but we also can add new variables as well. So even though isSolar is not part of my class object, I can actually add in a new attribute for my robot. So you can see here, if I print this out now, we can still see it says Wally, right? So now we actually have Wally's name, okay, versus none, which was the default. And I didn't change anything else, but I also added is solar, and is solar will actually come out now. Okay, so that's the way you can kind of change things out. Yeah, question.
Yeah, is there a way to just print out all the attributes at once? Like, is it easy? You know, like if I wanted to know like all of it at one go.
Yeah, I think I'm trying to think in Python. So the reason why I'm kind of going, because it's not a very common thing you would do. But I think technically you can. I don't know the exact code to do that. Yeah, and this is actually in the code later on. If you look at something called setters and getters, in practice, basically you don't want to just list off all the variables. You want to keep some of these things like hidden so someone doesn't accidentally change it when they're trying to do the code. Usually you use functions to either get the information or set the information, and those are called setters and getters. And the other one's deleters. But that's a little more advanced one too that we can maybe talk about maybe in the future as well. But I think there might be a way to list all of them. I don't know what it is off the top of my head. Okay, cool. But good question. All right, so now we can actually do some stuff. So, all right, here's some properties, right? Some attributes. We actually want to give it some functions, right? Have the robot do something. So class methods you'll hear people say methods and for classes and objects. Those are functions. That's literally what they are. Like they're just functions that are tied to a specific object or a class in some case. So sometimes you can actually make a method that belongs to the class. So this is going to be a little confusing at first, but just bear with me a little bit. So note that I gave it a property, right? So robots will have some attribute called law of robotics, which is basically just a list of the different laws of robotics. Okay, so this is just a list. And then I also can define functions within this class right here. So you can see I can do print laws, for example, okay, and I'll basically print out the laws, and I can print a specific law. So I made some functions. Exactly what these functions do, it doesn't really matter too much, but you can see there's some relatively basic functions. This one will print all the laws. This one will print a very specific law. Okay. So if I run this now, I now have a class robot, so I can actually use the class itself. So know that I didn't instantiate an object. This is belonging to like the mold itself. Like the mold essentially has it stamped on there, law of robotics, and the ways you can print out these parts. So I can do robot.law of robotics, and you can see that actual property go out through here. Okay, and then you can also do robot.print laws here. So you can see here I printed out all the laws here, and then I print out a very specific law, the second law. Okay, so I'm actually using the class itself. I haven't actually created an object yet. So these are called class methods. And sometimes you'll see this, built into specifically, like for example, if you do pd.dataframe and there's like a function like that, you can actually create methods that are specific to that class itself. So this is where it gets a little confusing where it's like, okay, well, what if we make a robot like Wally? So we make a robot Wally, right? Like we did before. Okay, we can see that he has the law of robotics built in, just like before. But this function, what if I want to call this function, right? This dot print laws. Well, if I try running this, you'll see that it doesn't work out. And the reason why is basically this print laws function, the way it's defined up here. Okay, if you do it like this, like you normally would write a function within the class, it is tied to the class itself, the mold, not the object, which isn't super useful in some cases, right? Sometimes we actually want the object to use a function, a method, right, specific to that object. So the way we do this, instead of having it tied to the class, is something called self. So basically here is we'll do something very similar to write the same stuff like a function. But in this case, we pass this parameter here called self. Okay, and this is basically a way for the mold to say, oh, the class to say, oh, this doesn't belong to the mold, the class by itself. This function speak actually belongs to whatever object is being made. So that's what that self is talking about. It belongs to the object itself. Okay. So in this case, you can see we have the same properties as before. Okay. In this case, you'll have some new methods that's going to essentially tie it to the object itself, right? So that's where that self comes in. So you have speak self, and then it'll print out just self.name. So whatever its name is, it'll print that out. And then this add numbers here, it's saying, all right, this self is the very first parameter, saying this is going to belong to the robot. And then you say, okay, you can pass in two other numbers, number 0, number 1, whatever the numbers two are, put them together, add them together, and then return that total. So if I do dot add numbers, we can actually add those parts up. So I'm going to actually split this out so it's a little bit easier for us to read. So I have Wally here. Oops, I should run this code first. There we go. So we can see here, Wally is now created, and we can see he's printed out with his name, metal, true, right, number of arms. Okay, and now if I want Wally to speak, all I have to do is do Wally.speak. Note I don't have to put in anything in that parameter, even though they're self, and that's because it's actually Wally is that self parameter. That's essentially what's going on here. So if I do this now, it'll actually print out his name. In this case, his name is just none, right? Since I didn't give him a name. But if I were to later on, like say, for example, I do Wally.name equals, we'll say Wally, right? If I write it like this, now he will actually say he's Wally. Okay, so it's basically using this self, and that's how we can reference that specific parameter, self.name. You can think of it as it calling Wally.name. Okay, and now we can do something similar with add names, or add numbers. So this is a little more complicated. So note that I'm putting in a number 101. Those correspond to number 0 and number 1. And then note that I have that self here. That's just saying this is going to belong to the object itself. Okay, so now when I do this, this will actually return 100 plus 1, which would just be 101. And you can see that's what I get here. Okay, any questions on this? This is probably might be a little mind-bending, but hopefully it's not too complicated. Cool, thumbs up, sound good? Cool, all right. So now we can do some stuff like, for example, I give it some name, I can say it's Wally. I can also, down here, I just was showing you, you can actually change this function if you want to. I don't recommend doing this. This is kind of something just to show you in principle you can do this, but this .speak is the actual functions. And so I can actually change this. And remember, Lambda gives us just a function here. So I can actually modify this function just to show you that that's all I'm really doing here. Okay, but note that I didn't have to actually do a self here because it's basically refining it to this part. But in reality, never do this. This is just something I'm just showing you, like it's possible. But in reality, is if you want a function to be called, what we say Wally, this robot or this object, this Wally object, is calling this function speak, or calling this function, or I should say method, add numbers. Okay, and that's kind of the terminology. Cool. Any questions on these parts? Cool. Sound pretty good? All right. So we have another little knowledge check. Woo. So this kind of leads us to the ending part. So we have a few minutes. So maybe we'll work on this together. Sound good? Or how about, I'm going to ask you guys, would you guys like to work on it together, or would you guys like to separate, kind of like work on your own and then pass it in, and we'll do a little show and tell?
Together is fun.
Together? I see some thumbs up like, yes, let's do this together. Okay, that's fine. All right, so, and I think that's a good amount of time too. So we're having a new thing called a functional robot. So our goal is to improve our functional robot with at least 2 object methods, right? So we actually want a method for it to do something. So we'll kind of like, maybe we'll kind of do another volunteer kind of thing. So we'll give it a default name of no name. In your object or your code. So we want to make a method. So any volunteers to first make our first method? All right, Jenny, reluctantly volunteering. Okay, and we'll help you out as we're going through it too.
Okay, cool. All right. Yes.
Okay.
Okay. Does it matter what it is?
Yeah, no, it doesn't matter. So what do you want? What do you want a robot to do?
Say hello.
Okay, so let's go ahead and start writing that part out. Good.
Okay. Yeah, I'll just have them print hello.
All right, cool.
Okay.
So there's our first function now. Easy peasy, right? Okay, thank you, Jenny. And then, okay, cool. Have control now? Awesome. So let's make another function. And this time, I'm going to say, let's make a function that takes in a parameter, right? At least one parameter. So it can be whatever you want. Any volunteers on what that function should do?
Maybe get the name. So ask what's the name.
Okay, cool. So Rebecca, do you want to go ahead and grab control and type that out?
Okay, try. Let's see. It's so, is it, okay.
Let's turn the volume. All right. So now you should have control.
Okay. Click to start the mouse keyboard control. Hopefully it didn't say. Okay. Okay. I don't know, something like that. I don't know if this will work out, but okay.
Try it out.
Oh yeah, so how did, yeah, I don't know. We didn't actually really, okay. Now what? Okay.
You could do like, again, like print and then do that F and then open parentheses. So like you're putting, like if you put an F before it, then you can make it like a dynamic print. Yeah.
An F string, right?
Like
F string.
That's it.
Yeah, and then say like my name is, and then self, like with the curly brackets, put self dot name within there.
else dot name or
Self dot
self
name.
name? Okay. Like this?
Oh no, like within the curly bracket.
Oh, within the, oh, right. Okay. Never mind. Yeah.
And I don't think that you need name comma self under the definition, but I'll defer to other people. I think you might just need name up there.
Oh, okay. But this would
I
be
mean, just
essentially
self, sorry.
the
Like,
self. Okay.
yeah, at the top under get name,
Mhm.
I think.
Well, I guess, Victor, you wanted us to pass in, you wanted us to create a method which,
That's okay. We can do this one first.
okay.
Mhm.
So,
So I think this one looks good, except I think there's one last thing. Do you guys see?
Yeah, you're going to need a closing quotation mark. There you go. Yeah.
Okay, I'll go put that there. Oops.
oh wait.
I did that. It's all right.
Okay, because
I didn't know if you had control still.
Nothing happening. I know.
Okay.
Impatient.
No worries. No. Okay. Cool. And then I'll go ahead and I'll work with you guys to add one right now. So Rebecca, do you still have control, or do you want to relinquish control back to me?
I definitely want to. Well, how did you put that in without? Okay, never mind. All right, should be okay.
Okay, cool. Yeah, I can always control it. It's just more like I thought you already stopped. So okay, so let's make a new function, right? That's kind of like put in a parameter. So let's say like, I'm going to say make a middle name. And I'm going to put self, and we'll put in middle name. Enough, right? Okay. So now that will take in a middle name, and we'll actually set this. So we can actually do print, my middle name is, and like what Laura mentioned, I love F strings. Just know that only Python 3.7 and above will let you do that. I think 3.6, but at least 3.7 will let you do this. So just know that you have to write version. And we're actually going to go ahead, and I'm going to blow your guys' minds, right? I'm going to set up a middle name here. So I'm basically going to make him have a middle name now. And so this way, I can now set this, make a middle name, and now that robot will actually have a middle name. Okay, so we'll run this guy, and our show and tell will actually be us trying it out. So let's go ahead and make our functional robot. We'll call it ClassBot. Okay, and we'll call it functional robot. We'll go ahead and instantiate them, right? And then we'll go ahead and run these different functions. So let me go ahead and run this guy. So now we have our ClassBot. Let's do ClassBot dot hello, or say hello. It says hello. Okay. Let's go ahead and do our ClassBot dot, what's the next one? Get name. Okay. In this case, we won't have a name. We'll just be no name, right? but you can see what is your name. My name is name. So cool, it worked out. And then we can do our class bot, and then dot make a middle name, right? So what's our middle name? What do we want it to be?
John.
Sunshine. Oh.
Sunshine John.
That's good.
Sunshine John. Okay, so we'll have that then, and then we'll go ahead and run this guy, and it'll actually print out what is my middle name is Sunshine John. So if I really want to combine all this together just to prove that it does work, we can actually do, let's see here. I'll just put this string in here. Is, let's see here. My name is, we'll call it, oh, we have class bot already. So class bot dot name, and then we'll put in his middle name, right? Class bot dot, oops, middle name. Okay, and so we print this out. My name is no name Sunshine John. All right. I don't know why, but that just tickles me so much. Like, I feel like a little kid. All right, so great job, guys. That was awesome. So you guys ready for, so that's kind of the end of our object-oriented programming. There's more in the curriculum, but I'm going to show you guys what our pair programming activity is. And this will be something we can share on Friday in our Friday fields, just to kind of share with the class. So you guys ready to see what this is? So we're going to have a little battle. You guys are going to design a battle between Mothra and Godzilla. So you guys are going to build the classes of Godzilla and Mothra, and you're going to, at the end, have be able to perform a battle, something like this, where we have our different objects, Mothra, Godzilla, and then they'll battle. So you'll define what battles means, okay, and it'll return a winner, and then we'll print out the winner. So you can modify this code a little bit. You can change it however you want. If you want to add some extra flair to it, that's fine too. But there's some baby steps here and just saying the different parts that you need, saying the animal type, the height, the weight, the battle cry. You can make this up. You can be as creative as you want in this part with your partner and have this go through. So I think you guys will have a lot of fun with this. I think it'd be kind of cool. So this is kind of like a little extra assignment kind of deal with your partner program pair activity. I think it'll be a good way to practice your skills and make it all work out. And then we can share it on Friday Fields. Also note that I put a little bonus here. If you want to, like, if you guys are feeling really good at it, you guys can also make it so you can inherit from the megafauna class to make dinosaurs and battle out dinosaurs as well. So this is going to be a little fun extra thing. Don't feel like you have to get to this part, but if you're feeling really good with your partner, like, yeah, let's make this work, you can increase this part and you can share with the class. Okay. So let's see here. Yeah, so this code now should be available. I'll send this out on Slack as well as partners as well. And so I'll make sure you guys have that, and then you guys can work on this together at some point throughout the week. You guys can find some time. I'm going to like, what's it called? Get together and like program together. If you guys need help, I'm trying to figure out a way to do that. Zoom is probably the easiest one, though I think you might be limited to a certain time limit. And then just maybe we can figure something else out as well. Okay. Sound pretty good to you guys? Cool.
Okay.
All right, awesome. So I'll put out partners out on Slack too, as well as the link to this thing. So you guys just copy this code and then you guys can create it and we'll share it on Friday. Oh, one last thing about this thing. Don't spend more than, I would say at the very most, an hour and a half on this project. Don't take too long. If you guys are feeling up for it and you're like, I'm feeling pretty good with the curriculum and everything like that, and I want to spend some extra time because it's a lot of fun, you're welcome to do that. But if you're getting, a little frustrated with it, or like, you guys are trying to make something work and it's taking over an hour and a half, go ahead and call it a day there. And you're welcome to message me for help as well, okay? Or each other for help. Cool. All right, everyone. Well, I'll go ahead and stop it here. And let me get stop recording.